Hi, my name's Jeff Hollingworth. I'm Head of Product Marketing for Ericsson Cloud, and this screencast is part of the Ericsson Cloud story. And what we're going to focus on in this screencast is the question, why isn't telco disrupting the world rather than the other way around? And what are we doing about it? So let's just go into a little bit of background about the telco, or more specifically the mobile industry. And recently, the report came out June 2015, the Ericsson Mobility Report, and it shows that by 2020, there will be 6.1 billion smartphone subscriptions, 7.7 billion mobile broadband subscriptions, and 9.2 billion mobile subscriptions. We have created the biggest distributed system on the planet. And what that really means is that even just in Q1 2015, 108 million mobile subscriptions were added. Now, if you work that out, that's adding over 13 mobile subscriptions per second around the world. And all of these devices can be turned on anywhere on the world and they just work. No thinking required. And that's absolutely incredible. There is no other system on the planet that supports that kind of technological interoperability or capability. Billing, settlement, security, policy. The only thing requiring thought is whether I have an adapter plug for the charger so I can actually charge the battery up. Now, we also know 5 years from now the world will look very different. This is an example of the Google car that's currently driving around the roads in Silicon Valley. Connecting and making one of these cars work reliably is one thing. Making 10 million, 20 million, 30 million all seamlessly work is another scale challenge. I would much rather this car worked more like my phone, where there is no thinking required and it does just actually work, versus perhaps an application on a PC today. So this new network society presents untold new opportunities for operators at the heart of connecting every person and everything. But this opportunity is threatened by disruptive internet-born companies that seem to play by different rules. They are disrupting now. The question we have to ask is, why are we not disrupting them? And if we take a step back and look at the system that we have built, there are certain characteristics that are important to understand. For starters, that we've built a massively scaled system, but it really does only 3 services: voice, media, and messaging. Media being data, of course. So we've really built a system that has done 3 services very, very well, and done them for a long period of time. If we look forward in the future, then what we see is that we're connecting everything else and connecting those things to people. And suddenly there is a requirement to launch thousands of applications, all of which may have very, very different lifetimes, from weeks to months to seconds to years. The ability to launch different applications with speed and agility is something that our system has never done before and requires us to rethink how we actually architect the system. From embedding the services as part of the infrastructure to one where we enable applications to be deployed on top of a platform of infrastructure. And if we look at the infrastructure today, there are really 2 systems inside there. There is a radio system and there is a core network system. The radio system is highly automated, highly governed, and highly driven as one orchestrated system. That is not true for the core networks of today. The core networks of today are not similar between operators, have been designed in an ad hoc manner, and the actual knowledge and possibility to instrument and program those core networks from a remote place is not possible today. The simple difference between the two systems is one where if you ask a mobile operator how many base stations are in your system and what are they currently doing, there is an immediate system to answer that. If you answer the same question of how many servers are currently in your network and what is each server doing, then that's a much harder question to answer. So what we need to do is transform the core network to being a highly programmable platform that enables applications to be deployed seamlessly on top of it. So going forward here, that really what we start to see is an infrastructure that enables any business rather than an infrastructure that defines your business. And very simply, there are three layers inside here. There is the physical layer, meaning the facilities plus hardware that make up the core infrastructure that the applications run on top of. And then above that is an automation and management platform that the applications and data use to actually be deployed upon and use as a programmability layer. The first people to understand the need for a platform were actually the public internet providers. And what happened with them was that when they started, they used a very traditional IT approach, very similar to how all enterprises are doing today. But when they hit success, they realized that they needed to do exponential scale, but they couldn't do exponential investment. So that's when they stopped buying from the traditional IT vendors and started making their own solutions, which is what we now call cloud. The other aspect is that they realized that if you have exponential growth, you can't have exponential operation. So the next step that they did was to automate as much as possible. And that's how they have enabled the actual exponential growth with the correct cost structure and with the correct automated operation. From the mobile operator point of view, it's not as simple a journey as that. By placing a cloud inside the operation, this does not solve the problem. It's just another piece of infrastructure, however highly optimized that infrastructure is. Because we have ongoing network and we have ongoing operations. So what we need to do is start with where you are. And then we need to move the workloads in a very structured manner over to the cloud optimized environment. And really what cloud is just the most efficient generation of IT infrastructure that exists today. So how do we do this? And what we speak about is something that we refer to as the industrialization cycle. And all industries and all businesses have actually flowed through this same cycle of optimizations. So this is not particular to cloud. And one of the best ways to understand this perhaps is to use a different industry that is analogous, that we can understand parallel to ours. So let's look at very simply the concept of farming before the industrialization era. And everybody, let's say in rural society, kept their own cow. So let's say that I have a cow, I call her Daisy. She lives in my backyard and I milk her once a day. The first thing that we want to do is actually find all the daisies and start putting them together where they can cohabit in the same way. So we're not going to keep goats with sheep, with cows. We're going to put the cows together. We're going to standardize and we're going to decide we're going to get milk from cows. So the first step is that we put the cows and then we place them in one field rather than my back garden. So what happens here is that we should, even if we have the same number of total cows, we start to actually share common infrastructure. There's one field, it has one fence, it has one trough for the cows to feed from. It has one supply of food, it has one supply of water. So we immediately get cost benefits even if we're not reducing the number of cows. Now there is a chance that we find a cow that can produce twice as much milk than the other cows. And that's when we can start to consolidate the number of cows we require to produce the same amount of milk. The next part of the industrialization cycle is the ability to program the cows. So what we want to make is that now the cows, they hear a bell, they all go to the milking station, they're all automatically milked. At no point are any of these cows actually touched by a human being anymore. Do they have names? No, they start to be known according to numbers. So Daisy no longer exists. Now it's cow C1289534, and it's one of, say, 500 cows. And we also want to be able to program, is the cow healthy? Can we make readings of it? What else can we control? So let's place implants inside the cows. Because what happens is that once the cows are actually programmable, then we can actually start to automate everything that we do with the cows. So as I was saying, now we're at a point where we can ring a bell, 1,000 cows get milked automatically without the intervention of any need for a human being to actually do that. And the last part of the cycle is the governance, because if you automate things and you start to produce things to scale, then you have to make sure that you have control over what is happening to avoid chaos. So the governance here, there tend to be six types of governance: performance, scalability, quality, economics, compliance, and security. So performance, are the cows producing the quantity of milk that we actually want them to have produced? Scalability, is it possible to increase rapidly the amount of milk produced, introduce more cows, reduce cows? Quality, is the milk good? Is it drinkable? Is it not sour? Is it not poisoned? The economics, are we getting the right amount of milk production per cow that we think the herd should actually be producing? Compliance, does it meet all the regulations? Has it passed all the criteria? And then security, we don't want anyone being able to get in and put something in our cows that makes our milk bad. So we have to make sure that the cows are secure, and we have to make sure then that there is no bad introduction of anything. And this cycle continues as you scale and scale and scale, and as you start to collapse more farms and more cows into one operation, until you have a hyperscale cow and milk production. This is exactly the same cycles for the technology that we're going through. So we standardize on x86 chips, standard rack design, standard sleds, standard components. Then we can start to combine, whereas we had separate servers before, we can actually start to place them in one facility at least. So now they share common heating, common cooling, common facility costs, common operations, and in some cases we can actually retire dedicated servers and put them on combined servers, so that now that utilization has gone from 10 to 20%, hopefully upwards to 60 to 80%. And then we can start to abstract and virtualize and make everything programmable inside that infrastructure, so we can manage those jobs, those workloads, our cow equivalents, not with humans doing manual things, but with automation and with the ability to program and discover and understand without the need for a human. And then the last part again is that we're doing this to scale, so we have to be able to govern these machines to make sure that we actually are meeting the requirements that the jobs and the customers have on top of them. And again, this continuously repeats as technology improves, as we bring more and more of the equipment under one industrialization cycle to build the scale. The end result of this cycling is we've moved from the legacy ad hoc operation to one standardized way of working from a facilities point of view, an equipment point of view, a hardware point of view, an operations point of view, an abstraction point of view, an automation point of view, and a governance point of view. And then we still carry on because technology does not stay in place, and it's one continuous life cycle of improvement to ensure that the economics are meeting the business case that's required according to best practice at any point in time. So this is the foundational approach underneath Ericsson Cloud, and this is why that we often refer to the comment that says that people don't need a cloud strategy, they need a digital industrialization strategy. This enables operators to innovate because it gives the agility and speed required with the right economic cycle. And it introduces the approach for doing this, which is the industrialization cycle. Ericsson is very committed to building this future. We believe that what we are building is a system that is industrialized to the same degree, that will require the same scale as the mobile radio networks that we already deliver today, that power those billions of subscriptions that we started with. So we're doing it very quickly, and we're driving disruptive change in the industry to ensure that we can bring the type of Google economics to the rest of the world. Thank you for listening. I hope that was helpful.